Today's video is going to be on the observed firing chart. We're still going to be utilizing the pivot point method. I just want to show you guys how to conduct a shift mission if need be on pivot point method. Alright, so if you want to follow along in the TC3 TAC 22.91, you can. It's on the the top portion of page 5 TAC 13. Alright, it's just labeled plotting of observer corrections. Alright, so going off of the data that I had for the last video. If you don't remember, let's go ahead and spin you up real quick. So we had an azimuth that we pulled off of our map, a grid azimuth of 5660. Alright, we got that. We needed to find our mounting azimuth, rounded that to the nearest 50 of 5650. Then we superimposed our refer deflection scale of 2800. And then from there, all we did is determine our distance from us to the target. And then we went up that distance from our pivot point on our vertical range scale, our vertical center line, and we made our plot. All right, so I saved that as target Charlie Hotel 0001. And now we're just standing by in order to conduct further on missions. All right. First things first, in order to conduct this shift mission, you need to know your observer's direction. All right, the azimuth in which the observer sees the target in mils. Once we have that, we can go ahead and make our corrections from our known point, so wherever we're shifting from. And all we're going to do is apply that new plot over our vertical center line to determine our new chart deflection, chart range, initial azimuth, and then something I'll be going over for the first time is computing angle T. All right, so for this example, I will give an OT direction, an observer target direction of 5860. So I'm going to index that azimuth on my plotting board. So 5860. Once I have that, I can go ahead and apply the corrections that the FO gives to us. So just a standard shift mission. We're shifting from Charlie Hotel 0001. We'll say he gives us a right 300, drop 300. All right, so there's two different ways that you can attack this. You can use your 1 in 25 thousandths protractor, or you can use your range arm. All right, this is strictly off of user preference. I will show you both just so you have an idea on how to utilize both. So if I'm using my range arm, I'm going to start with my range arm nice and parallel across my target. All right, if I had more room here, I would start at 0 just for simplicity, but I don't, so I will start, we'll say, with 15. So my range arm is nice and parallel with my green or black grid lines on my plotting board base. And then from here, I'm just going to count over 300 meters. So on my range arm, all right, each tick is 50 meters, and then you have each 100 meter range labeled as such. So if I'm using my range arm, an easy way is just to count 300. So I'm at 15, I'll go to 18. That's 300 meters, I can make a plot. All right, and I know my range correction was a drop 300. So from that plot that I just made, so now I'm just lining them up, still keeping it nice and flush with my lines on my plotting board base. And then I'm just dropping 300. So 100, 200, 300. Make a plot. I'm going to circle this and label it with a 1. So I went right 300, drop 300, and that gives me my new plot. Now, if I'm using my protractor, once again, I'm using my 1 25,000ths portion of my protractor here, because it's going to line up perfectly with my big black box on my plotting board. Now, the easiest way I've found to do this is to line it up with the correction that I'm going to be applying. So I know I'm going to the right and I'm going down. So I'm going to put my plot on this left top portion of my protractor. Now with the 1 25,000ths protractor, so each number is 50 meters. Okay, so if I look at my protractor, the 1 is not 100 meters, it's 50 meters. Okay, so I need to go double the distance or double the number. So if I need to move right 300, I need to index the 6 on my protractor on the target I'm shifting from. So I have 6 lined up. So I'm moving right 300, that's double the distance. And now I need to apply my drop correction of 300. So same thing, 300, they're increments of 50, so I need to go double the distance, so I should end up on a 6. I make my plot, I circle it, and label it with a 1. Now, once I have that plot, all I have to do is move my plot to line up on my vertical center line perfectly. Okay, so essentially all I'm doing, and we'll get into it later when I cover below pivot point, is I'm parallel line plotting from my mortar firing position, in this case is my pivot point, all the way up to my new point. Once I have that, I need to find my initial chart data. Okay, so just reading the deflection, my initial chart deflection off of my vernier scale. In this case, I get a chart deflection of 2687. And then my range is right off my vertical center line of 2350. I have a chart deflection of 2687 and a chart range of 2350. All right, my azimuth. So how I'm looking at it right now, if I'm reading right off my vernier scale, I have an initial azimuth of 5763. All right, so that is the azimuth in which myself at the mortar firing position sees the target. So now, in order to compute angle T, so there's a few things on the computer's record that I'm leaving out based on what round types and stuff you guys want to do, however you're filling out your FDC orders. I mean, you can utilize whatever. I'm not trying to canalize you by any means. But if I'm just following along in my initial chart data, I get down to angle T. All right, all angle T is the angular variation between the observer target line and your gun target line. So if I have the observer looking at my target this way, my gun looking at it this way, I'm trying to compute the angular difference or the angular variation between the two. All right, we'll get into that here in a second. All right, so we determine angle T to the nearest mil. So that's the number that we're going to find on our calculator. We're going to record to the nearest 10 mils. That is going to be the number we fill in our initial chart data on angle T line. And then we send it to the FO to the nearest 100 mils. All right, so many of you have probably heard the saying, pennies, dimes, dollars. That's all it refers to. The pennies is the number on your calculator. The dimes is the number you record on your computer's record in the initial chart data. And the dollar is the nearest 100 mils that you round it to when you compute it and send it to the FO if it's in effect. All right, when that angle is between 500 mils and 2700 mils, the FO must be informed. All right, so there's some extra steps that he may or may not need to take in order to apply to his corrections. So if it's between 500 and 2700, we need to inform the FO. And then angle T cannot exceed 3200 mils. All right, so in order to determine angle T, we have to compare the OT direction and the gun line, the gun to target direction, and subtract the smaller from the larger. All right, so say I give an example and I have an OT direction of 3200 mils. I have a gun to target line or gun to target direction of 2600 mils. I subtract the larger from the smaller, the smaller from the larger, and that number I obtain, that sum, will be angle T. All right, so 3200 subtract 2600, that gives me an angle T of 600 mils. All right, seeing how that number is already rounded to nearest 100, I don't have to do anything with it. All right, so 600 is between 500 and 2700, therefore I would pass to the FO, angle T is 600 mils. All right. Now say angle T exceeds 3200, what do we need to do? All right, so simply all we're going to do is add 6400 mils to the smaller number and then subtract, just like we did in the first example provided. All right, so let's say, just so you guys can see this, we have a gun target line of 6200. We have an OT of 0200. All right, so if we subtract the smaller from the larger, we get 6,000. Now we said angle T cannot exceed 3200. So all we need to do is add 6400 to our smaller number. That's going to give us 6,600 mils. Now I need to take that 6,600 and subtract the larger number in the equation. So my calculator says I now have an angle T of 400 meters. All right, so if we get a sum between our two azimuths that exceeds 3,200, we're going to add 6,400 mils to the smaller number. Once we have that sum, we're going to then subtract the larger number to obtain our new angle T. All right? All right, so for our example that we have on the plotting board. So I said our OT direction is 5860. The initial azimuth that we pulled off of this shift plot was 5763. If you subtract 5763 from 5860, you're going to get 97. All right, 97 is what we determined to the nearest mill. Now that I have that number, I need to record it to the nearest 10. So all I'm going to do is round that to the nearest 10, which gives me 100. So 100 would be the number that I write on my computer's record, on that initial chart data box. Now if angle T was in effect, which in this case it's not because it's not between 500 and 2700 mils, but if it was, then I would send it to the FO, to the nearest 100. So I determined to the nearest mill, I recorded to the nearest 10th, I send it to the nearest 100. All right, so now that I have all the information, I can go ahead and move into my initial fire command on my computer's record. All right, so depending on how you guys want to attack this, you can fill it in however you want. Say I had a section firing HE quick. I have gun 2 as my mortar to fire. And I was doing 1 round the adjust, 5 rounds procs in the fire for effect. I just pull my chart deflection over. So I have a deflection of 2687. Charge 4, which in this example I'm using 300 series ammo, which I can cover in a later video, the difference between 300 series and 800 series. But I'm using 300 series, my elevation of 0941. And then I can go ahead, send that data to the gun, and they can hang it and fire. All right, so the biggest way to be efficient on the plotting board is to get 1 step ahead of your observer. All right, now I'm not saying jump ahead and try to figure out the corrections that he's going to do. All I'm saying is simply index your OT direction, so in this case 5860, and stand by. All right, so as soon as he comes over the hook and he gives his corrections, if he has one, all I have to do is apply that to my last plot, hurry up, spin my azimuth disc back to my vertical center line, and obtain my new data. All right, so in a nutshell, without going over multiple corrections, we went over how to obtain data on observed firing chart pivot point method with a shift mission. All right, so once again, I just shifted from the target that I plotted in the previous video. I got a OT direction of 5860. I indexed that OT direction before I made any corrections. And then from my known point, I shifted right 300, dropped 300, and I made a plot. I circled it and labeled it. All right, then from there, all I did was rotate it back to where it's directly on my vertical center line. And then I can obtain my chart data. All right, then I went into how to compute angle T. All that is the angular difference between your observed target line and your gun target line on the target. All right, so that's the small chunk of the pie when you're thinking about angles. So remember, we compute it to the nearest mill, we record to the nearest 10, and then we send it to the FO to the nearest 100.